Hello dear students, in this video we are going to discuss about the Cobb-Douglas production function and Euler theorem. I have already discussed about the Euler theorem, homogeneous production function. So first of all you need to understand what is the homogeneous production function and what is the Euler theorem. Okay, suppose you have a production function Q is equal to Q is equal to function of L and K. Okay, and if we add some specific factor or multiply our inputs by a particular scalar, so our production function become like this. Sorry, this is the T, this is TL and TK. Okay, that must be equal to the T raised to power n and L k. Okay, if this condition is satisfied, it means our production function is homogeneous production function. And if we talk about the Cobb-Douglas production function form is like this. Q is equal to, in Cobb-Douglas production we are assuming that there are two inputs and this is Q, and Q is equal to A L alpha and K is 1 minus alpha. Okay, this is the Cobb-Douglas production function or a Cobb-Douglas production function. Okay, first of all we need to verify if this production function is homogeneous production function or not. Okay, for verifying a homogeneous production function, okay, suppose the f function is multiplied by the constant t. Okay, this is the constant t. Okay, add a constant t to each variable. Okay, variables are here L and K, and this is L and this is raised to power alpha, and K is raised to power 1 minus alpha. Okay, now we have to take common T. Okay, that is alpha plus 1 minus alpha, and this is AL alpha K 1 minus alpha. Okay, here you can cancel A and A. Okay, this is the production function now T1, and this is A L alpha and K 1 minus alpha. So you can see that we have successfully verified that this is a homogeneous production function, and T1 equal to a function Lk. It means our production function is homogeneous production function of degree 1, or in other words you can say this is the constant return to scale. Okay, I have discussed that this is the homogeneous production function of degree 1. Now we need to verify the Euler theorem. What is the Euler theorem? Euler theorem say that if L is multiplied to partial derivative of L plus K is multiplied by the partial derivatives of K, then it is equal to n time Q. Here n, that is the power of T, that is the 1, so we can write here a Q. L or marginal productivity of labor plus K marginal productivity of capital must be equal to the production function itself. Okay, now we need to differentiate our production function with respect to L. Okay, now we are differentiating a production function with respect to L, that is equal to alpha A L A minus 1, and this is the K capital 1 minus alpha. Okay, there is no change in K. We are differentiating production function with respect to L, so we are making a manipulation in L only. Okay, now we need to multiply both side by L. Okay, what is the L? That will be like this, L time, okay, that will be like this, this will be a 1 plus 1, okay, and it will be like this, alpha A L minus 1 plus 1, because we are multiplying L with L, okay, and there is no change in K, that is 1 minus A. We can cancel 1 and 1, and this is equal to alpha, okay, AL raised to power alpha, okay, minus, sorry, K raised to power 1 minus alpha, okay. This is our equation number 1, okay. Now we need to differentiate a production function with respect to capital, okay. We are differentiating production function with respect to capital, that is equal to 1 minus alpha, okay, A L raised to power A, and K 1 minus alpha minus 1, okay. Here you can see that we can cancel 1 and 1, okay, okay. And in second stage, this must be multiplied with the K, that is, it can be written as A alpha A and K minus alpha plus 1, okay. Further simplifying it, it will be 1 minus alpha, okay, the A L raised to alpha, and K is 1 minus alpha, okay. Now we need to add both equation. This is equation number 2, and earlier it was the equation number 1. We need to add both equation, okay. It will be like this, L with differentiation with respect to L plus K, and differentiation with respect to K, that must be equal to Q, okay. So adding both equation 1 and 2, okay, that is the 1 minus A and L and K 1 minus A plus alpha and A L A and K 1 minus alpha, okay. Now adding, we can see that the main difference between these two is, what is the main difference? 1 minus alpha and A, okay. And after simplifying these two, okay, we need to add these both of these, that will be something like this, alpha 1 minus alpha plus alpha, okay, and A L raised to alpha and K 1 minus alpha, okay. You can cancel alpha and alpha, and eventually I have a equation A alpha K 1 minus alpha, that is equal to our production function Q. It means Cobb-Douglas production function has been verified for the Euler theorem, okay. It means that our Euler theorem has been successfully verified, and this is equal to the production function.